Hello, I am Aayush
And I am Aryan.
and we are Team ECOPOWER.
So our theme is number 10, that is AI for renewable generation forecasting by KSPDCL and KREDL.
The core problem lies in the inherent unpredictability of renewable energy and its impact on on Karnataka's power grid. While the state has massive solar and wind capacity, power generation fluctuates widely based on cloud cover, temperature, and wind speeds, making it difficult for the departments to plan and schedule electricity distribution. So, inaccurate forecast for grid operators to rely on expensive backup sources or waste green energy. Through curtailment to prevent system imbalances, the challenge is to build a reliable AI driven forecast layer that can translate complex weather data into a precise plant level and cluster level predictions across diverse geographies. This solution must not only be accurate but also provide clear visibility into why behind the forecast and the level of uncertainty involved. Karnataka leads the nation in the renewable energy, but our grid faces a silent challenge variability. When the wind shifts or the cloud moves, the gap between the schedule and the actual power costs million in imbalance and insufficient backups. So, we don't just need a forecast, we need a decision support layer that understands uncertainty.
Our solution, EcoPower, is a high-fidelity renewable energy analytics platform that leverages physics-guided machine learning to solve the unpredictability of solar and wind generation. By integrating specialized LightGBM models with real-world physical parameters such as plane of array, irridance of solar, and hub height, corrected wind speed for turbine, the system delivers hyper-accurate plant-specific forecast. The technical architecture features a real-time data pipeline that fetches live weather metric every 15 minutes, runs physics-informed interference, and visualizes the result on an editorial grade dashboard. This allows operators to see overlapping actual versus AI predicted telemetry series, providing a distinct, separable outlook on future generation for optimized grid management and energy efficiency.
So what about the data we used? The EcoPower pipelines utilizes a real-time synthetic data engine to bridge the gap where physical SCADA SCADA telemetry is unavailable. While we don't have direct access to the on-site sensors, we fetch live, high-resolution weather data every 15 minutes for each plant's exact coordinates. We then process this real-time weather through advanced physics-based simulation models using PVlib for solar geometry and standard power curves for wind to generate synthetic actuals. This to generate synthetic actuals. This allows our platform to provide high fidelity representation of current plant performance. This is perfectly synchronized with the real world environment conditions, ensuring our actual and predicted telemetries are always grounded in live meteorological reality.
So you might be wondering how exactly we trained our machine learning model that is LightGBM. So our LightGBM forecasting engine was trained using a multi-dimensional feature set designed to capture the complex non-linear relationships of renewable energy generation. We integrated over 12 critical factors including global, direct and diffuse irridance, total cloud cover and cyclical temperance. To achieve maximum realism, we employed physics-guided feature engineering, transforming raw meteorological inputs and panel-specific plane of array, that is POA, irridance, and calculating relative air mass to stimulate atmospheric attenuation. The model was trained on a standardized baseline and then dynamically scaled using each plant's unique DC AC capacity, ensuring that the high fidelity AI outlook remains calibrated to the specific hardware and geographical constraints of each asset in our portfolio.
The major problem which we faced in this complex model was we were not provided with the plant level historical data which we could have used to train our LightGBM model. Unfortunately, we did not find any relevant sources on the internet. But the synthetic data which we have generated and used upon this to train our model is more than 96% precise and
If we are implementing this on a real plant, we only have to attach the plant sensor data along with the coordinates and capacity. In short, we have trained our model so well that it can be scaled or descaled according to the situation without retraining the model. So it simply points out to the scalability of our project. So this is a running page, 4 boxes: cumulative solar output, cumulative wind, accuracy, frequency. This is the graph of cumulative solar and cumulative wind plotted on a 48 hours. So, and there beside that there is an anomalies detected system which will notify you if there is an anomaly, which we have designed using various mathematical terms. And coming to the assets, this is one of our most important. We have actually got details of few real plants of in Karnataka. So here they are. The plant actually use the coordinates and all. So you can see the next 24 hours in dotted line, as well as real time actual generation as well as predictions in real time, and next 24 hours. In the bottom section, you can see the peak generation, average output, energy generated till now. That's it. Similarly for wind, it's the same. Yeah. Coming to forecast, it's actually the summation of all of them and presented in a graph. Nothing much here. Coming to analysis, this is a 15-minute regular which updates regularly and automatically, which will tell you if there is an anomaly. Anomaly in the sense if there is an generation error or something like that. So it will show you solar, wind, affected plants, as well as the reasons which are affecting the generation. So you can actually see it in real time, which updates in 15 minutes. So yeah, that's it. Thank you.